Okay, good morning. Let me turn it down a little bit here. Maybe that should be the one. Good morning, let's get started. I'm here today just give you an overview on water and wastewater treatment. And the presentation I'm going to use are based on my previous lectures on water and wastewater treatment. I combine them. And now you should have a copy of the six per page PDF file. And you can always go back to the books to find out all the slides on a larger print. Now we only have 6 hours. Okay, we started a few minutes late. I will make up the time here. So basically, the first line here. Okay, again, my name is Jeff Kuo. Give me 1 second here. Jeff Kuo here. Pay attention to my email. In case you have any questions regarding my presentation, my slides, you can always email me. Remember, you pay me to be here. So the first part here is water treatment. Okay, this part here is for water treatment. A few things we can learn. By the way, okay, I have quite a few samples. Those are P-exam samples toward the end. Also, I have lots of samples, examples throughout my lectures. Those are the previous samples from the NCES. I will cover them. Basically, for water treatment here, the first thing we know, the two sources for water here is from the groundwater and surface water. So that's something we know. And after that, we go through the water distribution system to industries and homes. So for this part here, it's more like water treatment. And after that, we will focus on wastewater treatment. Okay, wastewater treatment here, wastewater treatment plant. Toward the end, the wastewater will be discharged to rivers, lakes, or oceans. So we have to worry about the water quality. So we have two sewer systems, stormwater system, and sanitary sewer system. So nowadays, the trend is to have a separate system, but in some of the older cities, we do have a CSO, combined sewer overflow. That's called the CSO. Okay. And for wastewater treatment, terminology is very important. So we have to know so-called the preliminary treatment here. Okay, I'll let you know what is that. And followed by primary treatment. The only process we have for primary treatment is primary sedimentation tank. So throughout your test, we talk about sedimentation, clarification. Okay, they are the same for water, wastewater. Okay, then most of the people have problem with secondary treatment. That's a biological process. Okay, it's pretty complicated, but fortunately, I think your test is a multiple choice format. So I will cover the things you need to know. I'm pretty confident I will cover things you need to know. Okay, for wastewater, the other part we have to worry about here, sludge. Okay, sludge here, so we have a so-called sludge treatment. Sludge and anaerobic digesters. Then we have a lot of dewatering and the sludge will go out. One more time, we have preliminary, primary, secondary, and may have some tertiary process, not here. Tertiary process and go into a river. Okay, that's so-called advanced treatment here, advanced treatment. Don't worry, we'll cover all this. Now, it's very important for you to take a look at the next few slides. These are on the NCES specs. It means what do you need to know? At least maybe they give us some hints what kind of questions they will ask about water, wastewater treatment, water quality. So this slide here, let's quickly go over. This way help us to go through my slides. So water distribution system, water treatment process, including all this. This can be part of the water treatment process, right? Then we talk about demands. How much water? Okay, storage here maybe more like an equalization tank, equalization basin. Okay, then after that, sedimentation, taste and odor control. And this part here, this most of the time people put this together here, coagulation, flocculation here. So I want you to have idea what's the difference between coagulation, flocculation. Then we talk about filtration, disinfection, and water softening. So the things I can say for the main difference between water and wastewater is for water, okay, we don't talk about coagulation, flocculation much for wastewater. We don't talk about hardness and softening much. So this part here is not really for wastewater. Okay. Then the other are the same here. So that's the reason I combine my slides. It turned out to be a good way for us to cover both. Okay. And for wastewater treatment, we also have a sludge to worry about here, but wastewater sludge is more complicated because wastewater we have more organics. So the main things beyond water treatment you need to know here is for the biological process we talk about in wastewater treatment. Okay, so again, this is nothing but for the water treatment. The next one here, wastewater treatment, will be in 2 slides. The first part here is more like a wastewater collection system, opposite to water treatment. Water treatment, we talk about water distribution system. So the good water going out to the household. But this one here, we collect the wastewater from the household here. So it's pretty interesting here. So same principle, we should have a network of a system to collect collect the wastewater or distribute the water here. Same thing here, we have a wastewater treatment process. As I mentioned, we have a preliminary, primary, secondary. Okay, and most of the time, secondary people talk about biological process, and people put this one here more toward the tertiary treatment. So somehow the people come up with the specs. I'm just kidding here. May not know wastewater treatment too much. Okay, and flow rate is the things we have to work on here. Flow rate here. Okay, we have for wastewater, we talk about peak flow. We have to worry about here. Peak flow here. So that's lots of questions will show up. Okay, you have to have the concept how to deal with the peak flow or average flow. Okay, preliminary, primary, secondary. Okay, and this one also, these are for the nutrient removal. Okay, phosphorus, we will not talk about this much. Okay, but the idea, I will show you what do you have to know about phosphorus removal. But in California, in the past 10 years, 15 years, now we have to worry about the nitrogen removal here. So for these two will be for the nutrient removal. Okay, and this part will be the sludge. And this is related to the sludge treatment here, digestion. Okay, and disinfection, as I mentioned earlier. So okay, again, advanced treatment here, most of the time people talk about, okay, beyond the secondary treatment. The next slide here, stream degradation. Stream here, most of the time we talk about lake, but more commonly we talk about river. Okay, and we talk about oxygen dynamics. Okay, we talk a lot about DO, dissolved oxygen. That's part of the question here. And TMDL, some of you in the regulatory agency nowadays, past 5 to 10 years, people talk about TMDL. I will give you some idea. TMDL may be also related to the load, total maximum daily load allocation here. And talk about biological contaminants, okay, and chemical content, bioaccumulation, the concentration factor here. So basically, I think I will cover most of the questions you will see. So bear with me. I think after that, if you can master my slides, you'll be fine. Okay, if not, you send me a nasty email after the test. Okay, but I'm very confident. I've been teaching here for almost 20 years. Okay, I always got good feedback. Anyway, this one here is just want to let you know here water and health. So two important things. Definitely, for water to be safe, we have to do lots of coordination. Okay, but the reason I put this slide here, I want you to know, okay, people most of the time always have filtration, okay, before disinfection. The purpose for that is to remove the things cannot be disinfected effectively. So filtration. Why filtration? First thing, the other things I want you to know the purpose of each process. Filtration is to remove solids, right? What kind of solids? Suspended solid. So I'll let you know what kind of suspended solids will be removed by filters, okay? And disinfection byproducts, the one topic you also need to know, okay? So should the water be potable or palatable? So basically, I'm not going to spend all the time here, but I think you can go through my slides. Okay, potable here related to the safety here, right? So I just want to mention two species you have to worry about here for water treatment is so-called Giardia and Crypto. Cryptos for reading. Okay, so we have Giardia and Crypto here. Okay, the reason for that, these two species about 10 micron in size. So for 10 micron, normally for bacteria, sometimes bacteria can be 1 micron or even smaller than a little bit smaller than 1 micron here. So 10 micron is 1,000 times bigger, larger than 1 micron here. We know the formula, by the way, you know that, right? This is a volume of a sphere. So it's very hard to disinfect these two. So that's the reason we want to have filters before disinfection. Hopefully, the filter can take out the particle size larger than 10 microns. Okay, so those will make disinfection easier. So we have other things to worry about here. We have pesticides, okay, insecticides, or lots of chlorinated or disinfection byproduct, DBPs, disinfection byproduct. That's for the safety. The other one here, this is palatable here. Okay, we don't really care about the health, but we worry about whether it's aesthetically pleasing here. So we worry about TDS, taste and odor here, and corrosivity, color, things like that, turbidity here. So for both. I think today, for you people, you are going for the water resource and environmental engineering, I believe. Okay, so we want to be both. And by the way, for water here, we talk about Safe Drinking Water Act, right? Okay, and we talk about MCLs. Okay, the things you have to know, MCL and MCLG. I saw some sample questions. You really have to have a concept of MCL. MCL is more like a limit, but MCLG is a goal. I will show you that. Okay. So we have primary MCL and secondary MCL. So I don't want you to pay all the attention to all these details, but may not be a bad idea to have information here. But a few compounds you may want to pay attention to, like a nitrate and nitrite. Okay, nitrite, the current limit is 10 for drinking water. Pretty interesting in California for wastewater discharge, the nitrite limit can be less than 8 or even lower. So somehow it's not safe to dump the drinking water into river here. Okay, don't pay attention to all the details. Well, we have VOCs, but just pay attention to some specifics here. And okay, again, that's too much. Okay, but okay, I just want to give you a general idea. The DBPs, disinfection byproduct, THM, the current limit is not 100, it's 0.8. Okay, and this one keep on dropping. Okay, the point here for MCLG is 0.06 ppm. Means the current water is not safe to drink. It's not safe. Okay, it may not be that safe, but the water treatment plant people cannot handle that, so they need time to adjust their system. Okay, so all the numbers I give you here, okay, may not be permanent. People keep on changing that, but you should have some good idea about all this here. But pay attention to MCLG. MCLG, okay, MCLG considered as safe here. So also have a lot of safety margin. There's one simple question here. You have the idea. So MCLG means the water is safe, and also we include a huge safety factor here. So for example, people find out maybe I just use a number here, 1 milligram per liter is unsafe. To be on the safe side, or maybe they find out 1 milligram